Hello guys, welcome to Applied Electricity with NK StudySync. We'll be going through the course outline for Applied Electricity. First on the list is the basic elements of electric circuits. We will discuss active elements. Under active elements, we will talk about the concept of charges and sources, including current sources and voltage sources. We'd also discuss passive elements, and the three main passive elements we discuss are resistors, capacitors, and inductors. Then we move to the concepts of short circuit and open circuit. And the concept of open circuit. We also discuss voltage drop, and current division. Then we move to the circuit laws. Under the circuit laws, we have the two main circuit laws: Kirchhoff's voltage law and Kirchhoff's current law, KVL, KCL, as they're usually termed. Then we would move to the network theorems. First on the list is Thevenin's theorem, then Norton, superposition, and the reciprocity theorem. We'd also discuss how Thevenin and Norton are similar, with the relationship between Thevenin's voltage, VTH, and Norton's current, IN. After the circuit laws, we will discuss delta star and other network theorems as well for resistances. So star, delta. Then we would move to AC circuits. Under AC circuits, we would apply the circuit laws and network theorems that we applied in DC circuits into AC circuits. But there's slight differences where we have sinusoidal voltage sources and current sources. We will discuss how we can find their effective values and average values for both current and voltage. We'd also discuss phases and phasor diagrams. And after phasors and phasor diagrams, we would move to the addition and subtraction of sinusoidal quantities and impedances as shown on these phasor diagrams. We have three main impedances. We have XL, XC, and resistance as well is an impedance. XL is inductive reactance. XC is capacitive reactance. And R is the resistance we know of from DC circuits. Then we move to current in AC circuits. So here, the simple example of an AC circuit. Then how current moves in an AC circuit and how to find the power in AC circuits as well. Then we move to how we can represent phasors as complex numbers. Usually in applied, we use J to represent the complex number I, because I is used to represent current. And how we can use complex numbers to solve AC circuits. After fully exhausting AC circuits, we would move to three-phase circuits, and we would discuss the relationship between line and phase voltages and line and phase currents. We would also move to the types of three-phase loads, mainly star and delta. We'd also discuss power in three-phase circuits, which is usually represented as S is equal to, where S is the apparent power, P is the active power, and Q is the reactive power. Then we would move to three-phase 4-wire supply and three-phase 3-wire supply. How we can supply power using three-phase with the two different types of supplies. Then we'd move to magnetic circuits to finish the course. Under magnetic circuits, we'll discuss magnetomotive force, usually termed MMF. We'd also discuss the BH curves of materials, usually drawn So we talk about the BH curves of both magnetic and non-magnetic materials. Under magnetic materials, we discuss ferromagnetic materials, paramagnetism, and diamagnetic. And we'd also discuss reluctance under magnetic circuits, where reluctance is synonymous to resistance in electric circuits. Then to finish it off, we would analyze magnetic circuits and learn how to model them like electric circuits to be able to solve equations. So we learn how to model this magnetic material into an electric circuit. Where we have our MMF so we have our flux. So we have flux flowing through the magnetic material. And then the windings which have currents flowing through them. So the source of the MMF. Then we have our reluctance in the magnetic material as our resistance. So this brings us to the end of the video. Please like and subscribe and share the video with your course mates as well. We hope to see you in the next video. Thank you very much. Bye.